I'm Dr. Carl Schreck. In this final video in our series, I'll be telling the story of resiliency that our region demonstrated in preparing for a storm similar to Hurricane Helene. Now, of course, one of the major challenges in the weeks and months following the hurricane was that the city of Asheville went almost 2 months without drinkable water. And a lot of that was because of issues at the North Fork Reservoir, the main water source for the city. However, things could have been exponentially worse. Fortunately, that reservoir had been upgraded in 2021, and those upgrades included adding an auxiliary spillway that allowed the primary dam to withstand a probable maximum precipitation event, or a PMP. And specifically, the new auxiliary spillway was designed to start automatically opening for a 1 in 1,000 year storm event, which is what happened during Hurricane Helene. Now, a 1 in 1,000 year storm doesn't mean it's going to happen once every 1,000 years, that we're safe for another 1,000 years. It means that it has a 0.1% chance of happening, a 1 in 1,000 chance of happening any given year. This is one of the images shown by the city and the county during their daily briefings after the storm to demonstrate just how challenging it was going to be to restore water service to the city of Asheville. What it's showing here is a 36-inch wide water main that connects Asheville to its primary reservoir. And that water main was buried under tens of feet of soil and rock, and it's still washed away. So the first order of business was to restore this water main, and that they were able to do that remarkably quickly. However, even once they restored it, there were still issues at the primary reservoir. The North Fork Reservoir, where Asheville City gets most of its water, is fed directly by these mountain streams. And so it's typically pristine, clean water, so they don't have to do very much filtering to it. However, Hurricane Helene caused so much rainfall that there was tons and tons of mud and silt that flowed down the mountains into the reservoir. And it took them months to figure out how to remove that silt from the water, that sediment, so that they were able to start treating the water and make it drinkable again. Now, even all of that aside, things could have been exponentially worse. You see, this dam is classified as a very large high hazard dam. High hazard doesn't mean that it's going to fail at any given moment. It means that if it were to fail, there is a lot of stuff downstream that would get washed away. So you really, really don't want that to fail. So knowing that, back in 2021, they made some upgrades to it. Specifically, they raised the primary dam by about 4 feet, trying to accommodate what they call a probable maximum precipitation event of 28 inches in 24 hours. And I think the largest I saw from Hurricane Helene was about 13 or 14 inches in 24 hours. So this would have been twice that value. In addition to raising the dam 4 feet, they also added this auxiliary spillway that was designed to help relieve pressure off of that primary dam. And here's a photograph of the auxiliary spillway after it was installed. And you see these fuse gates along the entrance of the spillway. Those are designed to automatically open one at a time to relieve pressure off of the primary dam. This isn't anything that anyone has to monitor, decide, is it worth releasing water to save the primary dam or not. No, this happens automatically from the force of the water rising pushes these gates open. They're designed to start overtopping during a 200-year event, and they're designed for the first gate to start opening at a 1,000-year event. And that's exactly what happened during Hurricane Helene. That first gate opened and helped relieve pressure off of the primary dam and help keep the primary dam safe. And the reason that's so important is if that primary dam had failed, the water treatment plant is just down the hill from that primary dam. So if the primary dam failed, the water treatment plant likely would have been completely washed away, and it would have taken many, many months to restore water to the city. And so that's why they say things could have been exponentially worse. Now, part of what's interesting about this story is that they were able to make these designs based on data that's housed right here in Asheville at the National Centers for Environmental Information, where they collect all of this weather and climate data, not just for our region, but for the entire country. As I mentioned in a previous video, I've been a CocoRa's observer since I bought my first house back in 2012. And that means that every morning at 7 a.m., I check a rain gauge just like this to see how much rain is in it. And I record it so the National Weather Service and others can know where the biggest rainfall events are happening. And these are the largest rainfall events that I have observed at my house. And Wednesday night going into Thursday morning of Hurricane Helene, I observed 6.5 inches of rain, which, based on all the data that we have here at the National Centers for Environmental Information, is a roughly 1 in 500 year event. So a 0.2% chance of that happening in any given year. Just the next day, I had 2.7 inches, which we estimate to be about a 3-year event. So a 1 in 3 chance of that happening in any given year. Now, I also mentioned in a previous video how Western North Carolina is really unique for having the wettest place east of the Mississippi just 50 or 60 miles away from the driest place east of the Mississippi. So my house, I'm a little bit north of Asheville and Weaverville. So I'm closer to the driest place east of the Mississippi. So I'm also going to be comparing the observations that I had at my house with some of the ones that are closer to that really, to the wettest place in Brevard. So first, this is a graph from NOAA Atlas 14 for my house. Atlas 14 takes all of the data that we store here in Asheville at the National Centers for Environmental Information and uses all that rainfall data to estimate how frequently different intensities of rain might occur. And so as you go left to right on this graph, you can see that as a rainfall event gets longer and longer, it's not surprising that you get more and more rain. So that's why the x-axis, the left to right, is how long the event is. The y-axis, bottom to top, is how much rain falls in that event. And the colors tell you how likely that event was to happen. So green is a 1-year event. You can expect something like that is probably going to happen every year. 2-year event, 50-50 chance of it happening in any given year, all the way up to a 1,000-year event that has a 0.1% chance of happening in a given year. So at my house, the largest one-day total that I had was about 6.5 inches, which falls almost perfectly on that light blue 500-year line. But then if we look at my 3-day total of about 10 inches, that was a little bit over a 1 in 1,000 year event. Now, if we go to one of the other CocoRa's observers closer to Brevard, which is near that wettest place east of the Mississippi, their highest 24-hour total was just over 13 inches of rain, which right there, that falls right along the 1 in 1,000 year event for Brevard. However, their 3-day total was just shy of 30 inches of rain. 30 inches of rain is just about double their 1 in 1,000 year rainfall total. In fact, it would be a 1,000-year event for 45 days of rain at that location. So this was way, way outside the expectations for that area. Now, one reason that could be is we know very well that as the climate is warming, a warmer atmosphere can hold more moisture. And these really extreme events, they're really good at wringing that extra moisture out of the atmosphere. When NOAA calculates these things for NOAA Atlas 14, they assume that all the events in the record are equally likely. So if an event happens in 2023, was just as likely to have happened in 1923, for example. But we know with climate change, that's not really the case. We know that these extreme events are becoming more and more frequent. So several of my colleagues are actually working right now on what's going to be called NOAA Atlas 15, where they're going to update these charts to take into account how a lot of these extreme events are happening more and more often in recent years. I'm really curious to see what that's going to show for Hurricane Helene. So in this final video of our series, I've told the story of resiliency for our region, where it was really hard for the residents of Asheville to go a month without any water in their houses to flush or wash their hands, and almost 2 months without drinkable water. However, things could have been even worse. Fortunately, they had upgraded the North Fork Reservoir back in 2021 to withstand a probable maximum precipitation event, or a PMP. And specifically, they added this new auxiliary spillway that was designed to start automatically opening during a 1,000-year event, like we saw with Hurricane Helene. If that spillway had not been in place, it's possible that the primary dam might have failed and water would have started washing away the water treatment plant, and things could have been exponentially worse, not to mention all the other stuff that's downstream of the reservoir, like the town of Swannanoa. So it's really interesting to me that this definition of a 1 in 1,000 year event, that's produced for civil engineers by NOAA through NOAA Atlas 14, using the data that's housed right here in Asheville at the National Centers for Environmental Information. And they produce those numbers not just for Asheville or Western North Carolina, they do that for the entire nation. And so this was an example where the data that we house here in Asheville actually played an important role in preparing our region for a storm like Helene. So civil engineers, they really need to be able to build these dams and these bridges to understand what a worst case scenario might be. And our data helps them do that.